Hello, how you doing? It's MrDoTheMath, and today we're going to talk about angles, right? So, in order to talk about angles, you got to know what they are. Angles are rays that share the same endpoint. The same endpoint. All right? Angles are rays, bam, that share the same endpoint. Okay? We talk about these endpoints. This endpoint is known as the vertex. This endpoint is called a vertex. Okay? So, there can be more than two rays that create an angle, right? You can have angles all over the place, right? But right now we're just going to concentrate on having just two rays, right? Two rays because we're going to talk about next naming angles, right? And just like we were just talking about the segments and the lines and rays and stuff like that, there's a sign that signifies that we are naming an angle. The sign looks like this, right? And so to name a ray, you can name it one of three ways, right? If I was to put points here. Let me see. Give me a letter.
A.
A. Give me a vertex. C and
B.
All right, A, C, E. Right? So, to name an angle, the outside letters are always first or third. All right? Always first or third. So, A will go first. C, the vertex is always second. Always second. And the other outside point is third, ace, right? Or you can name it the other way around, E, C, A, right? So you can go this way, as long as the vertex is second. And when you only have two rays connected to the same endpoint, you can name it by its vertex, right? You can name it by its vertex. So it could be angle ACE, angle ECA, or angle C. Okay? That's how you name it. Now, when I add another ray to this angle, I can no longer name it by its vertex because we have multiple angles there, right? So only when I have two rays can I name it by like the vertex. Okay? So this is naming. All right? So the next thing we want to talk about is the protractor postulate. What is this? Well, I'll kind of let you know, right? You guys, have you ever used this before?
No. In 7th grade.
You only use it like once.
Do you know how to use it?
No.
Cool. All right, let's learn. All right, so this protractor is used to measure angles. It's used to measure angles. And in our homework, we're going to guess. So, for instance, there are steps to naming or measuring an angle, all right? Protractor. Sometimes I used to get mixed up between a protractor and a compass. Those are the two most popular tools you use in geometry. A compass is the thing with the pen and you spin it around, it helps you make circles, right? And then you got this thing. Y'all never seen it before?
No, we didn't.
Yeah. So back in the day, the compasses only came in metal, and the point was like super sharp. And I remember in elementary school, like I accidentally poked myself in the web of my hand, and it didn't bleed though. But anyway, so protractor used to measure, right? Step one. The first thing you want to do when you're trying to measure angles using a protractor is you want to line up the vertex. Line up the vertex with the middle of the protractor. Right? Line up the vertex with the middle, right? Then the next thing you want to do is you want to line up zero with the bottom line of the angle, right? With the bottom line. So you got 0 here, and the bottom line here. All right? So you got that lined up. And then finally, what you want to do is you want to find the second line. Sometimes your protractor is going to be bigger than the angle, right? So like for instance, if I had the same protractor and I tried to measure an angle in a book, what I would need to do is I would need to extend this line, right? But here it's perfect for us because the protractor and the angle are like both big. They're both big. So from here you line them up, and so you start at 0, and we're going in this direction. This looks like this is at 45 degrees. All right? So that leads to our next point. All measures of angles are in degrees. All right? So then 45 degrees. Now, if the angle is going this way, and I said I wanted to know the measure of this angle, we'll do the same thing. Line up the vertex with the middle, and line up the bottom line. The new bottom line is going to be this angle here, this line here, which means that you're going to count in this direction. Whereas earlier we were counting in this direction, you're going to count in this direction. And so we're going across. We found the bottom line. We matched up our vertex, and it looks like this is going to be at, that's 90, that's 100, 110, 20, 30, 130. So is that 100, 10, 20, 30. Say like 32. 132, 133.
Could you add?
How?
90.
All right, so look, what happens is
90 plus 50.
you go to 90.
Oh, yeah.
After 90, you keep going.
Oh, I see.
So like on your handheld protractors, what it's going to do is going to count from 0 to 180, and it's also going to count from 0 to 180 in the opposite direction. Okay? So after 90, it doesn't go to 80, it's 100, and it keeps going. So this is 100 and, like we said, 132 degrees, right?
You wrote 130.
I did 3, yeah, 32, 33, 32, right? So that leads us to our next point, right? So we know how to name angles. We know how to use a protractor a little bit better, right? And so there's the next thing we do called classifying. Didn't I say I was going to stop saying so much? Classifying angles. Okay, classifying angles. We have 3 main types, well 4 technically. 4 main types of angles, right? We have acute angles. What's the next one?
Obtuse.
Very good. Obtuse. What's the next?
Right.
Right. Then what? Very good. Straight. You have straight angles, right? Each one of these 4 classifications give you a threshold, a measurement. Acute angles, they fall between 0 and they're greater than 0 and they're less than 90. Greater than 0, less than 90. Obtuse angles are greater than 90 and less than 180 degrees. Right? So based on our protractor, from here to here is acute. From here to here is obtuse, right? So acute, obtuse. Then you have your right angle. That equals 90. Right, it's 90 degrees. And you also know you have a right angle when you see an angle and it has this like box on the inside of it. That means 90 degrees. And then finally you have a straight angle, which equals, very good, 180 degrees, right? And so a lot of times you know that you have a straight angle when you have this line, when you have a straight line, right? This is 180 degrees. This won't add up to 180 degrees, but this is 180 degrees right here, okay? All right, we're good so far.
Yeah.
Classified angles. We named angles, we use a protractor, we got our classifications. Next step is this new postulate we have here. So what does postulate mean again? What does postulate mean again? Can't say so. Postulate. The postulate is what's one word? The postulate is starts with a R. U-L.
Rule.
Yeah, postulate, rule, right? we have this new postulate here. It's called the angle addition postulate. Angle addition postulate, right? And that basically means that if I have three angles that are connected to each other, three angles that share the same vertex, angle addition means I could add these two angles together to get the sum of the big angle. All right? So, the angle addition postulate means, two angles. It's two angles sharing a vertex. When two angles share a vertex. So if two angles share a vertex, then the sum of those two angles is the measure of the big angle. Alright? If two angles share vertex, then the sum of the two angles is the measure of the big angle. So, two angles. Alright, so if I say A, B, C, and this is D. What I'm saying is two angles share the same vertex B. That's saying ABC, angle ABC plus angle CBD equals angle ABD. Okay? We good so far?
Yeah.
Alright, so simple geometry terminology says this. If ABC equals, let's say, 40 degrees, right? And angle CBD equals, say, 60 degrees, right? What would the measure of ABD be? 100. Right, that's it. If ABC equals 40 and CBD equals 60, ABD equals 100 degrees.
How does it equal?
Wait, how's that?
Because you add 40.
How does it equal?
I'm just adding 60 to 40.
That's.
Oh, I think each side is equal. Like 40, it'd be 40 and 40.
No, angle addition. This angle plus that angle equals this angle, right? This angle is 40 plus this angle being 60 equals the whole thing being 100. Okay? Now let's make it more fancy, right? Let's make it fancy. What if I got three angles? It's got three angles here. Right? Let's give me some letters.
A, E, F.
A, E, F. One more letter.
D.
C.
Oh.
Right? If AEF equals, let's see, 2x plus 10, and this one FEC equals 4x minus 3, and they say that angle AEC equals 145 degrees, what would be the measure of angle AEF? Okay? What we would do is, thank you. What we would do is set up the angle addition postulate, right? So we say this angle plus this angle, right? So that's 2x plus 10 plus 4x minus 3 equals 145. That's much like the problem in our on our quiz, right? So here, what's the next step? Yeah, combine your like terms, right? Combine your like terms. So that's 2 and 4, 6x, 10 minus 3, 7 equals 145. Right. Subtract 7 to both sides. X is going to equal what?
138. No, 137. 138.
138. 7 and 5. Alright? Then we can divide.
By 6.
Divide by 6. X is going to equal what?
23.
23. So x equals 23, but that's not what we want. We want to know how big this angle is. Right? Yeah, so you substitute 23 in. So CE AEF equals
56.
2 times 23 plus 10. Say what now?
I said 56.
56 degrees, right? That is incorporating the angle addition postulate, okay? Here's one more example of that. All right? What if I have this situation going on? If I got it like this, right? And I said that this angle is 10x minus 5, and this angle is 4x plus 3, okay? Let me see, it's TRXQ. How would I set this one up? Yeah. Very good, very good. So this is a straight angle. So you add these two angles together and set them equal to 180 degrees. Very good, Kaden. So that's 10x minus 5 plus 4x plus 3 equals 180. So whenever you see an angle like this, like a straight line and something going through it, you have 180 degrees you're dealing with. So you combine your like terms. 14x minus 2 equals 180. Add 2 to both sides. 14x equals 182. Divide 14. X equals what?
13.
13. 13 equals x. Then from there you plug it back in. Okay? One last point, and then I'll let you go. One last point. When anything is the same, they're congruent. Congruent means the same, right? With angles, these marks mean congruent. With angles, those marks mean congruent. So if I was to draw this here, and I said this is this, this is this, this, and this, these would be equal, and those would be equal. Okay? These two would be equal. Okay? And then from there you would set them equal to each other like we usually do if we're trying to figure out the angles. Okay? So this is pretty much it for angles. Alright? We'll elaborate more on it on Tuesday. Do we have any questions? How do we feel about it? Like, yeah? Okay, cool. So I'm gonna give you homework in a second, but don't forget to like and subscribe.
It was 120.